Just like yesterday, remember, you can multiply two square roots together to get another square root. But if it was, and then you can simplify this, right? You guys remember how we simplified it? The doubles come out, and the other one stays behind. Okay, but if we add a normal number, rational number times the square root, it doesn't really do anything. So just like you can multiply square roots together, you can also divide square roots together. On number 1, 4 and 25 don't really divide, but we can simplify what's the square root of 4? 2. And what's the square root of 25?
5.
So that's just going to be 2/5. By the way, this square root of 4 over square root of 25 is the same thing as square root of 4 25ths. Okay, these two are identical. They're just written differently.
Oh.
Okay, so if you see this, it means this. That's what I'm saying.
So do we
Okay, number 3. Now, square root of 5 divided by square root of 4. Do those divide? No. 5 divided by 4 doesn't work very well. But what can we do though?
Simplify.
Square root of 4 can turn into
Ghosts.
2.
Wait, so even if it's
Once we leave section A, we're all gonna die.
how do you know when to put the square root sign on?
Cube roots.
When you don't produce
Well, this one has a square root of 4. It's 2. But this one doesn't have a square root. Okay, now we could do square root of 4 and simplify square root of 8, like with the tree. But the easiest way to do this is just divide them first. What is square root of 8 divided by square root of 4?
Square root of 2.
Square root of 2.
Square root of 2.
All right, now let's see what would happen. Can I do anything with square root of 2? No, that's easy. But let's see what would have happened if I did it the hard way. What's the square root of 4?
2.
2. What's the square root of 8?
2 square root of 2.
Whoops.
Square root of 8 is 2 square root of 2.
2 square root of 2.
Yeah.
Okay, and
The
then
2's cancel out.
2 and 2 can actually divide because those are both real rational numbers. So it's just square root of 2. Now, it was a lot easier if we just did square root of 8 divided by square root of 4 is square root of 2. So if you can divide the numerator and the denominator, you should do that first. It makes it easier. But if you can't, you just have to try to simplify the top and the bottom. Can we divide anything on number 7?
Yes, the square root of 10.
Yeah. Square root of 10 and square root of 5
Square root of 2.
reduced to square root of 2. So just like you would reduce a 10 and a 5 to a 2 and a 1, technically down here it's square root of 1, but what is the square root of 1? 1 times 3 is 3, so it just goes away. So square root of 10 divided by square root of 5 is square root of 2, so what do you guys think the answer is going to be?
3 square root of
Square root of 2 over 3.
Bro.
Got it?
Sure.
Yeah.
Yeah. Okay, all right. Now, on 19, this is new. This is a new idea. Can I do anything with square root of 13?
No.
No. But here's the thing. They decided that the simplified form, you cannot have any square roots in the denominator. So you're not supposed to leave it like this. The reason is because you can't really compare different things. if you don't have the square roots in the same place. So the way we get rid of square root of 13 out of the denominator is multiply it by itself. What happens when we do square root of 13 times square root of 13?
Comes
Square root.
1, and it goes to
Square root.
You squared it. You square it.
I squared it, but what does that do?
Oh, you just like
Yeah,
times it.
doesn't
Let
it
me do a smaller example. What if I did like square root of 3 times square root of 3?
Square root of 9.
What is the square root of 9 though?
3.
3.
Whoa.
Is that a coincidence?
I think not.
What's the square root of 5 times the square root of 5?
5.
Square root of 25, which is
5.
5. Why does that keep happening?
Because there's.
That's how the whole math
Okay,
thing
when you square a square root, when you take a number times itself and then square root it, it cancels out. So whenever you take a square root times itself,
It becomes
what's this going to be?
3. 3 over 13.
13. Okay, you guys get it? Whenever you take a square root times itself, it just becomes that number. Top square. So that's how you get rid of the square root on the bottom. But to keep the value equal, whatever you multiply to the bottom, you have to multiply to the top to keep the fraction equal.
Oh.
So what's 3 times square root of 13?
3 square root of 13.
3 square root of 13.
Oh.
So it's kind of like we move the
That's the answer?
square root to the top.
Bro.
Yeah.
makes
Okay, listen, I'll go through it again. This over here doesn't really simplify, but they don't want you to leave the square root in the denominator. So the way that you fix it, you get rid of the square root in the denominator, is multiply it by itself. But if you multiply a fraction by something, you have to multiply it on top and bottom. Because when we multiply by square root of 13 over square root of 13, what are we multiplying by? 1. Anything over itself is equal to 1. So when you multiply by 1, it doesn't change the value. This value is the same as this value because you're multiplying by 1 basically. Anyway, when you do square root of 13 times square root of 13, it's just going to be 13. That's just like these where square root of 3 times square root of 3 is 3. Square root of 5 times square root of 5 is 5. The top, 3 times square root of 13 doesn't really simplify. So it just stays like that. Okay, moving on. Number 11 is kind of the same deal. We're not supposed to leave, I can't really do anything here, but we're not supposed to leave a square root on the bottom. So how do I fix it?
Times square root of 6 on the top and bottom.
Times square root of 6 on top and bottom.
So wouldn't it just be square root of 16 then on the top?
Okay, what's 1 times square root of 6?
Square root of 6.
Square root of 6. What's square root of 6 times square root of 6? 6. Does this reduce?
Yes.
No. Remember yesterday we didn't multiply a normal number in a square root? You can't divide a normal number with the square root. So that is all it is. Number 13. Okay. They wrote the division symbol on 13. I'm going to go ahead and write it with the division bar. Square root of 14 divided by square root of 21. I would not multiply top and bottom by square root of 21 here because there's something we can do before that.
Cancel.
7.
Okay. Just like you can reduce 14 over 21, you can reduce square root of 14 over square root of 21. You can divide both of these by 7, or square root of 7 technically. So if you divide this by square root of 7, what's it become?
7.
Square root of 2.
Square root of 2. If I divide this by square root of 7, what's it become?
3.
3. So could you do like the entire square root over the 2/3? But that doesn't work.
Yes. But we're not supposed to leave the square root of 3 on the bottom.
Oh, right.
So we got to work on it a little bit more. What do I need to do?
Times by square root of 3. Yeah.
Times by square root of 3. So what do you guys think the top is going to become?
Square root of 6.
And the bottom?
Square root of 3.
3. It's square root of 9, which turns into 3, right? So that gets rid of the square root on the bottom.
I don't know what we're thinking
Okay. What? I feel fine actually.
Nobody is.
I feel perfect.
Bro has a blanket.
Bro has an entire. It feels fine in here, bro.
It's fine.
Yesterday I was warm, but today I'm fine. Sorry.
It's because yesterday it was like 80 degrees.
Maybe you can get Gianna to fade you off. See.
Yeah.
Any idea? Well, before I multiply by like square root of 15, what can I do before that?
Divide by
3,
square
5.
root.
Okay.
Cancel out.
5 and 15 reduced to
5. 1
1
and
and
3.
square
Square
root.
root of 3.
Okay, now square root of 1 we don't really need to put because it's just a 1 and just disappears. Okay, so I got 3 over square root of 3. Now what do I do?
Multiply by square root of 3 on both.
Multiply by square root of 3. What will the top become?
3 square root of 3. And then you cancel out the 3.
Okay, yeah. This is the first time this happened. The 3's, since they're both normal 3's, we can reduce those like a normal. What's 3 over 3 reduced to?
1.
1. And what's 1 times square root of 3?
Square
Square root of 3.
I like that.
You make me
Giggle.
need the word.
You guys quoting a physics on or something?
No. We just think the word giggle is funny.
Giggle is so.
I heard
Giggly
I heard what Roman said.
Bro,
Giggle is so giggly.
honestly though, Clay just likes to giggle. Like that's every time.
Bro, Miss Taylor said giggle, bro. And Clayton goes, oh, she said giggle. What?
All right.
Wait, I thought that was me, bro. I was the one
So,
she said giggle.
if you have a nice calculator, 1 through 16 it can do it. But 17 it cannot.
Oh,
What's different about 17?
I can't tell if
It's
that's a
cube root.
Cube root.
It is a cube.
So I could rewrite this another way. I could write it as cube root of 1 over cube root of 2. This might be painful, yeah.
How come my calculators can't do
I don't know. They just didn't make. Maybe it's harder to program. I feel like it wouldn't be that hard to program, but they just didn't for some
They're
reason.
lazy. That's what they do.
Well, if it was easy, I'm sure they would have done it because that would make their calculators better than
Call of
other
Duty
people's
does it.
calculators.
They also got walk.
Evidently,
they
it
also
might
got
be
walk-
hard. Okay, do you guys know what the cube root of 1 is? Shh. 1. Because what 1 times 1 times 1 is 1, right? So that just kind of is nothing. Okay, now we cannot leave the radical in the denominator. But here's the problem. If I multiply by cube root of 2, is that going to solve my issue?
No.
I will get cube root of 4, but does cube root of 4 actually, does 4 actually have a cube root?
No.
No. What does have a cube root?
Cube root of 8.
Right. If I multiply by, math injury.
Since it's a cube root, wouldn't you have to do it 3 times? So instead of doing it twice with the normal
Okay,
square roots, you'd have to-
Yeah, 2 times 2 times 2, that's going to have a cube root, right?
Yeah.
So if we do it a couple times,
Actually, it's a few.
1, 2,
Pineapple. Pineapple.
Bro, that was coming out either way, bro. I don't really thought that was good. I thought.
seeing if I can get him to flinch. You're in the splash zone. Might need a tarp on the front row.
I want one of those like COVID plastic shields.
Isn't it kind of like everybody has a unique skin, you know?
Mrs. Stanley says it's
I know.
like
It's like a Nah, yeah,
It's like an
it's literally a
You're
bro.
like a cow. So bad.
Cows don't sleep.
Like, bro, just
let it out!
Yeah, let's deal with that.
I have like a tree.
Okay, shh. So, instead of just doing 2 times 2, if I do 2 times 2 times 2, I would get cubed root of 8. Now, does cubed root of 8, does that actually have a cubed root?
Yes.
Yeah. It's 2. But if I multiply the bottom by cubed root of 2 and cubed root of 2,
You have to do the
I
top.
have to multiply the top. I probably should have put that one
man.
there. Now, instead of doing times cubed root of 2 times cubed root of 2, I could have just put
Times cube root of
times cubed root of 4.
So could you do done cube root of 2 squared?
Well, we could, I guess. So what's 1 times cubed root of 4?
A number.
Cube root of 4.
Cubed root of 4. It's a little bit trickier, right?
Yeah, that's a bit of an understanding.
It's a little bit tricky.
A little.
Okay, do you guys know what the cube numbers are?
3.
I think we talked about this earlier. Shh, shh, shh. 2 cubed is 8. This is kind of important information for this. 3 cubed is 27. 4 cubed is 64. Probably won't need anything bigger than that. But all these numbers actually have cubed roots. Nice cubed roots. There's not a lot of them. They're very specific. So if we want to get rid of a cube root, if we can turn it into one of these numbers, that would be good. Of course they can get bigger, but I don't think the book's going to do that to us. Number 19, cube root of 9 over cube root of 36. Now, before I try to fix the cube root on the bottom, there's something I can do first that will make this problem a lot easier.
Magic. You can simplify.
Right. What do 9 and 36 reduce to?
3 and 12.
Okay, yeah, but you can do more than that. You can divide both by 9. So that would be 1 and 4.
4.
Okay, now cube root of 1 is just 1, but cube root of 4, we gotta fix it. How do I get rid of the cube root on the bottom?
You have to cube it 2 more times.
Well, I could do times cube root of 4 times cube root of 4, but
Cube root of 8.
trust me, you don't want to do that. It'll be a big mess. So here's a number that has a cube root. We did it last time, remember? That's much smaller. So if I can just turn it into one of these, I should be good. If I did times 4 times 4, it would work, but it would require a lot of work.
I saw that.
So what do I actually just need to multiply by?
Root of 8. Or cube root of 8.
No.
Or yeah.
Restart.
Hey!
Because I just want an 8, because 8 actually has a cube root.
Oh.
I have to restart. Hold on.
Yeah.
Okay, it would be much easier if I just multiplied by cube root of 2. Because this actually is going to have a cube root.
Oh, okay. That makes sense.
I don't understand.
100
Either.
1,000.
Shh. 4 times 2 is 8. 8 is one of the numbers that has a cubed root. Okay, I don't need to do times 4 times 4. That would be 64. That would work, but it will require a lot more simplifying on the top. It would take a long time. If I can just turn this 4 into an 8, that's much smaller and easier to work with. It will require much less work.
So it doesn't matter what number we choose to multiply.
Technically, we could have done times 4 times 4. The top would have been a mess.
Could you have done times 3 if you wanted?
Wait, so what's the
No, you need to turn it into something that actually has a cubed root. Because this 4 already has 2 2's in it, we just need one more 2. Okay, so the top is cubed root of 2, right? And then the bottom is cubed root of 8, but what is the cubed root of 8? Yep. 2. So that's why it works.
Oh.
That's why we wanted an 8.
I still get it.
So it would go away.
See, I say oh. Like
Trying to
I
see
know.
how many dead-eyed stares I'm getting.
I read this.
But
Well, I can't see the. I don't have it. My eyes are like
Numbers.
alive.
Hamburger, cheeseburger, Big Mac.
Alright, maybe I'll help you guys on one of the evens. Well, okay, like on, yeah, let's just do 21. Maybe I'll come back.
I swear, I literally barely have No.
Okay, what could I do first on 21?
You can simplify.
Yeah, both of those are divisible by 5, right?
Yeah.
So,
1 and 5.
okay,
Square root of 5.
cube root of 1 over cube root of 5. Now, how do I fix the cube root on this one? 5 is not going to go into any of these. We really need to turn it into 125. So you could say times a couple of 5s, or you could say times 25. But what's the cube root of 5 times cube root of 5 times cubed root of 5 going to be?
125.
Cube root of 125, which is 5. Okay, but on the top, times cubed root of 5 times cubed root of 5 is...
Cube root of 25.
Why are you only doing 2?
Why would I do more than 2?
I don't know. I don't know why you're doing 2.
Yeah, no, Eli's.
To get rid of the cubed root, we need to turn it into a number that has a cubed root.
I choose
So
last
why
chapter. This.
Foil looks so good right now.
Okay, this is
Yeah.
125, which turns into 5. So it's a normal number now, not a cubed root,
What did we even do last time?
which is what we were trying to do.
Yeah, no, it was just.
A little bit painful, huh? 23. Maybe I'll come back and help you guys with a couple evens. Leave one.
I totally agree.
Uh,
Help us with 18 to 26.
Let's go with that.
all right, 23. I'm going to write 23 with the division. For some reason, I feel like the division bar makes it look easier.
Yeah.
So let's write it like that. 14x3 y5.
Do we subtract exponents in this one too?
Yeah, because you can divide square roots, you can divide the x's.
We're not.
How do we divide the x's?
Subtract it.
Subtract the exponents.
But we can simplify it.
The 8 and the 14, what does that reduce to?
4 over 7.
And then what's gonna happen to x3? x3 divided by x3 is
0, cancels out.
cancels out. y3 over y5. Y to the second on the bottom.
Wouldn't it be negative? Oh, it's.
It'd be y to the negative 2, or it's y to the 2.
Oh, Mr. Jordan, the top x is the x to the 4th, not x to the 3rd.
Bummer.
Well.
Okay, what's 4 minus 3?
1.
1, so there's 1x on top. Okay. Before I try to fix the bottom, there's something else that I see that we can do. You guys see it? Shh.
No, I don't.
Oh.
Oh, you can take the y out. Right.
Take the squared out.
No, you can't. Take
Oh,
what?
you can.
Oh, that's, you can reduce it. Or like
Oh, it's
2.
2 square root of
Square root of 4 is
2.
2.
Oh, 2 square root.
So it's 2 square root of x.
Wow.
Alright, now, how am I? Oh yeah, we can take the y out. I didn't even notice
Yeah.
that. What we could, square root of y squared is
Y squared is 7.
y, yeah. Okay. Now I can't leave this, the y is fine, I can leave it there. But the square root of 7 is an
Oh,
issue.
right.
So how do I fix the square root of 7?
Times it by square root of 7.
Alright.
So you
What do you guys think the top's gonna be?
2
Square root of
squared
over square root of 7 times square root of 7 is 7.
So 7.
Y.
That's a lot.
Yeah, it's kind of hard, isn't it?
Starting the biggest number that can go into those numbers. Square root.
When you mean when we reduced 8 and 14? Yeah. It's just like reducing any fraction. It's just square roots instead of.
No.
All right. Let's stop there, I guess. We'll go to 24. I might have actually put that on the web too. I couldn't remember.
Don't take it back this time.
Yeah, no taking it back.
I'll give him my.
Here it is.
Okay.
Should do all the back page for us.
Let's try 18 and 22, and then I'll leave 20 for you guys to try. Let's try that.
How about 22 and 24?
Nah, 24 is yours also.
Poo-poo.
All right. Cube root of 1/9. So when they write it as one fraction, I usually split it up. Cube root of 1, cube root of 9. Probably less confusing. Cube root of 1 is just 1, but I'll leave that alone for now. So what do we do about the cube root of 9 down here?
You can multiply it by.
Does 9 have a cube root?
Yes.
No.
No.
It has a square root. It's got a square root, right? Because it's 3 times 3. So since there's already 2 3's in it,
One more.
if we just give it one more, 27 does have a cubed root. So I'm going to multiply by 3. Let's get that equals on there. So the top is cube root of 3. And the bottom is cube root of 27, which is 3.
That's not too bad.
It's the same as the other problems, it's just the third time you've seen it. Okay, 20 is easier than 22, so I'll help you guys with 22. Cube root of 5, cube root of 12. Does this one reduce any? 5 and 12?
No.
No, it doesn't.
Wait, but 3 can something? Are we not supposed to put the 12 can?
Don't you do it. Don't do it.
Okay, when I say reduce, I don't mean this thing. I don't mean simplify the cube root. Actually, cube root of 12 does not. I mean, when you reduce a fraction, it's like 6 and 8 equals 3 and 4. Like that kind of reducing. Not simplifying the radical. Okay, well, this one's a little bit hard. So, I guess we'll just do it the long way. Cube root of 12 and cube root of 12. If I multiply it by 12 and 12, that will have a cube root, right? There's actually a smaller number that would have worked, but I don't want to try to explain how to find it, so we'll do it this way. Do you guys know what the bottom is ultimately going to be?
12.
12, good job. And the top is going to be a mess. 12 times 12 times 5. I think it's 720, I believe. Okay, the problem is 720, even though it doesn't have a cubed root, it's going to simplify. This is why you don't want to use necessarily the biggest number over here, because you got a lot of cleaning up to do on the top now. But maybe the best way to do it. 720. What goes into 72?
2.
What else?
12 and 6.
12 and 6. 8 and 9, right?
2.
2 and 6 and 2 and 3.
Yeah, and then 2 and
This
2.
is the
Easton.
2 and 2.
this is the Easton specialty 2.
It's even, so it goes into it.
Okay, so but because this is a cube root, we need triples, right? So I spy with my little eye. 222. Are there any other triples?
No, so it's 9 times 2 times
I think we
5.
all thought of that.
So a 2 comes out.
90. Square
What's
root
left behind? 5 times 2
10 times
times 3 is 30 times 3 is 90. 90.
Wait, but then couldn't you cancel out the 2 and the 12?
Yes. The 2 and the 12, since they're both rational numbers, will reduce. 2 and 12 reduce to 1 and 6. Shh. So it's 290 over 6.
I messed up. I accidentally did 22 and 24 spots.
Why is it spicy?
24 is easier than 22
That's not
because it's
true.
square roots, not cube roots. Alright, now I'm done.
Okay.
Now I'm done.